Good day and welcome to episode 4 of Fractions. Today we're going to be adding and subtracting mixed numbers using the first method. Please make sure from episode 3 that you're familiar with adding and subtracting common fractions before you go on to this. And let's have a look at what method 1 is going to tell us to do. In method 1, we're going to be adding or subtracting the whole number part of the fraction first and then separately adding the fractions. Remember that a mixed number is made out of a whole number part and a fraction part. So we need to be very aware of that from the previous episodes, and let's continue now to see how to add these two together. So if I just look at the whole numbers, I've got 2 plus 1, which is equal to 3. And then from episode 3, remember that if your two common fractions don't have the same denominator, the first thing you have to do is make sure that they do have a common denominator. And the trick we use for finding the lowest common denominator, the LCD, is to look at the two denominators and choose the highest one, which is 8. Then ask ourselves, can 4 divide exactly into 8? Yes, it can. So then set up your two fractions with denominators of 8 so that you know what you're going to be dealing with. Remember also that if the denominator doesn't change, then the numerator doesn't change. In this case, the denominator did change. The 4 became 8. So we ask ourselves, how did 4 become 8? We multiplied it by 2. Whatever we do to the bottom, we do to the top, and the numerator will now become 2. So my whole number is going to remain 3. Don't forget to bring it down every time. And then because the denominators are the same, I can add the numerators, and 2 plus 1 is 3. The only thing I then need to decide is, can that part, the fraction part, be simplified? Well, nothing can go into 3 and the same thing into 8. So that is my final answer, 3 3/8. Let's have a look at a subtraction sum now. And again, we're going to work with the whole numbers first and then with the fractions. So looking at the whole numbers, 7 minus 2 is 5. And then looking at our denominators, we've got a denominator of 5 and a denominator of 3. So we look at the bigger one, 5. And then we consider, can 3 divide exactly into 5? No, it can't. So I go to the next multiple of 5, which is 10. Can 3 go into 10 exactly? No. Go to the next multiple. Can 3 go exactly into 15? Yes, it can. So that's going to be my denominator. So all I do now is I set up something over 15 minus something over 15. At this stage, I don't worry about what the top is going to be, because that can be confusing to try and think of all of that at the same time. Everything I'm doing in orange, you could just be doing in your head, or if you're scared you're going to make a silly mistake, then rather just do it in pencil, or some people even do it in pen. So how did 5 become 15? I multiplied it by 3, so I have to do the same to the numerator, and the numerator will be 12. How did 3 become 15? I multiplied it by 5, which means I must multiply that by 5, and 1 times 5 is 5. So again, I must remember to bring down my whole number. The denominators are the same, so now I'm allowed to subtract the numerators, and 12 minus 5 is equal to 7. Again, let's check. Is there anything that would divide into 7 and into 15? No, so that part is in its simplest form, and my answer is 5 7/15. Now we get on to things that require a little bit more work. So let's take the example of 3 2/3 plus 4 3/4. So again, I'm going to add my two whole numbers first. 3 plus 4 is 7. Then I'm going to test for my LCD by choosing 4, which is the higher one of the two. Can 3 divide exactly into 4? No. Try the next multiple. Can 3 divide into 8? No. Try the next multiple. Can 3 divide into 12? Yes. As soon as you've ascertained that, then put down your two denominators. Here you're just setting up your denominators, you're not worrying about anything else. Right, now we need to see this denominator did change. So how did 3 become 12? We multiplied it by 4, multiply the numerator by 4, and we have 8. 4 became 12 by multiplying it by 3. Do the same to the numerator, and I've got a numerator of 9. So now keep my whole number. My denominators are the same, which allows me to add my numerators. 8 plus 9 is 17. And here we've hit a little bit of a problem because this is not a common fraction. It's an improper fraction with the numerator being bigger than the denominator. So we're going to keep our whole number of 7, and then we're going to break this up, remembering that anything over itself is equal to 1. So if I take 12 of those 17 and I put it over itself, 12 over 12 will be 1. But then I had 17, so 12 plus what will give me 17? 12 plus 5. So all I've done now is I've broken the 17 over 12 into 12 over 12, which is another way of saying 1, and 5 over 12. Let's check back. The denominator is 12. Is 5 plus 12 17? Yes. So this here means exactly the same as that. And the reason I've done that is because now I see that out of this whole improper fraction, I have one whole. And that one whole has to be added to the 7, so that will become an 8. And then I'm left with the 5 over 12. It is now a common fraction, so all I have to do is to check are 5 and 12 divisible by the same number? No, so it is in its simplest form, and that will be my final answer. Let's look at a subtraction sum that also requires a little bit more work. So again, I'm going to start with my whole numbers. 6 minus 3 is 3. Look at my two denominators. 5 is the bigger one. Can 2 divide into 5? No. Next multiple of 5. Can 2 divide into 10? Yes. Set up my denominators. Right, how did 2 become 10? I multiplied it by 5, so do the same to the numerator, and I have a numerator of 5. How did 5 become 10? I multiplied it by 2, multiply the top by 2, and I have a numerator of 8. And now I have a bit of a problem, because I cannot say 5 minus 8. So just like here, when I got an extra whole number, I added it onto the whole number. Here, I'm going to have to take from the whole number to make a fraction. So I'm going to take 1 from the whole number. So 3 is now going to become 2. And I'm going to think of that whole number that I've just taken from there as 10 over 10. Because I think you'll agree with me, all of my fraction things here are dealing with denominators of 10. So what is the best way to say 1 as a fraction? 10 over itself. But then remember, I still have this 5 over 10. So that 10 over 10 is going to get added onto the 5 over 10, and I still have minus 8 over 10. So the borrowed 1, which is 10 over 10, plus the 5 over 10 is going to become 15 over 10. So I still write down my whole number, which is now changed from 3 to 2. 15 minus 8 is 7 over 10. And again, nothing will go into 7 and into 10 exactly, so it is in its simplest form, and that is the final answer. I hope this has been helpful. If you found any of it tricky, go back to the previous episodes first and then rework through this episode.